My name is Ryan Chin. I'm a PhD candidate and research specialist at the MIT Media Lab in the Smart Cities and Changing Places research group. Smart Cities and Changing Places is very much focused on the problems of urban mobility in general, the problems of energy, congestion, pollution, all happening in cities. And the fact that cities are getting much more dense and heavily urbanized, particularly in the developing world, is the research area that we're very concerned with, because that impacts energy, it impacts transportation, it impacts general mobility within cities. And so our research is really focused on tackling some of those problems and looking for synergy points between solutions in those areas. One of the big problems in cities today is that cars take up a lot of space in cities. In fact, some cities have almost 40% of the total land devoted to either parking of vehicles or the road network. And so we think that one of the big challenges is how to reduce the overall impact and footprint of vehicular traffic in cities. One of the reasons why cities sprawl and get bigger and bigger is because we take up a lot of land for parking. And often the biggest problem in cities is actually finding a parking space as well, so you have an overflow of vehicles. The other challenge in cities is that a lot of the private vehicles that we use are gasoline powered. And because of that, they create carbon emissions and other types of pollutants into the atmosphere. And that's really a collective problem. No one individual is responsible for this, but collectively we're adding more greenhouse gases to the atmosphere. So this negative externality, which is all of the pollution and all of the congestion that you get in cities, it's really hard to tackle that problem because it's a general collective problem for society. And one of the challenges for our group is to look at solutions that can address not only at the individual level personal mobility, but also collective mobility. And that would include not only how you integrate this into public transit, personal vehicles, rapid transit, and other modes of transport, including walking and bicycling. All of those modes contribute to the overall emissions of CO2 into the atmosphere. And so we're very interested in looking for solutions that are ecosystem level solutions that address each of those areas. One of the solutions that we've looked at is, of course, electrification of transport. And that's really to look at creating new types of vehicles that move away from petroleum-based fuels, electric vehicles in particular, and also making vehicles very lightweight. So in our group, we've actually designed 3 electric vehicles for cities, particularly for cities where trips are very short distances and the speeds aren't very high. And lightweight is is great for this because it doesn't take a lot of energy to move around. And if you electrify the vehicle, you have greater energy efficiency as well. So because of that, we've designed 3 different types of electric vehicles. The first electric vehicle that we've designed is called the City Car, which is a 2-passenger electric car. The vehicle is very unique in that it's very lightweight. It uses in-wheel electric motors in each wheel of the vehicle. Each wheel is independently controlled, so we have a completely new platform for the vehicle, which gets away from transmissions and drive lines and simplifies the vehicle. By doing that, we can control each wheel independently so that the vehicle is highly maneuverable. We can basically turn the vehicle on itself. It has a 0 turn radius. And because we've put the drivetrain in the corners of the vehicle, we have freed up the whole interior chassis of the vehicle, which means that we can actually fold the vehicle up, which is something that we've been very much interested in. The whole idea of being able to fold the vehicle is to compress the overall footprint. We can get the vehicle very small and take up very little room. And because of that, we can fit 3 cars in 1 traditional parking space. And because of that, we can then look at how this will affect urban land use. The second vehicle that we've designed is called the Robo-Scooter, which is a lightweight electric motor scooter. It uses the same principles of the City Car, where we have light in-wheel electric motors. It's an all-wheel drive bike. It also folds as well. It's very lightweight. It uses about 1/10 of the parts of a traditional motorbike. It has a lightweight aluminum frame, so it doesn't have a lot of cladding on it. And it's about half the weight of a regular bike. The third vehicle we've designed is called the Green Wheel Electric Bicycle, which is an integrated in-wheel motor and battery system that plugs into any standard bicycle. So you can take a standard bicycle that has a 110 millimeter wide rear frame, take out the rear wheel, plug in a new wheel, which we've designed, and you basically have an electric bike. The electric bike provides motor assist to the user. So you can basically pedal, but then you can turn on the motor and it'll help you overcome a hill or travel longer distances. So these three vehicles combined together form the basis of a mobility on demand system.